She is the USS Virginia, the invisible hunter that reshaped how humanity fights beneath the sea. The 15th submarine of the Virginia class, USS Colorado, is a machine built for silence and dominance. She stretches 377 feet from bow to stern, dives beyond 800 feet, and moves through the ocean at speeds greater than 25 knots. On paper, those are just numbers. In reality, they represent one of the most important shifts in naval warfare since the Cold War. The Virginia class was born out of a moment of uncertainty. When the Cold War ended, the U.S. Navy faced a hard question. What should the next American attack submarine actually be? The Seawolf class had just arrived, an engineering monster designed to hunt Soviet submarines in the deep ocean. But each Seawolf cost roughly $3 billion. That kind of price only made sense during an all-out arms race, and that arms race was over. With the Soviet Union gone, the Navy needed something different. A submarine that was cheaper, more flexible, and still lethal. One that could dominate the open ocean, but also operate quietly in shallow, crowded coastal waters where future wars were likely to be fought. From that rethink came the Virginia program. Asterisk, you can see this system in action in Electric Boat. Groton remains the heart of the program, but much of the heavy steel work begins farther north at Quonset Point, Rhode Island. There, workers cut thick steel plates, roll them into enormous cylindrical sections of the pressure hull, and stand them upright beneath cranes taller than buildings. While those sections are still open, crews install piping, pumps, tanks, electronics, and miles of cable. Everything possible is fitted before the hull is closed. Instead of crawling through cramped spaces later, workers operate in open, well-lit areas. When finished, the sections are rotated, aligned, and welded together like giant puzzle pieces. This modular construction is one of the key reasons the Virginia program stayed affordable and on schedule. The Virginia class also became the first U.S. submarine designed entirely in 3 dimensions. There were no stacks of paper blueprints. Engineers built a single digital model of the entire submarine, down to individual pipes, valves, and cable trays. If 2 systems tried to occupy the same space, the conflict appeared on screen long before it became a problem in the shipyard. That digital twin also made upgrades far easier. New electronics, rearranged compartments, or improved systems could be tested virtually before a single piece of metal was cut. One design choice changed the feel of the submarine more than any other. The Navy eliminated the traditional optical periscope. In its place came photonics masts and camera towers that rise through the sail, but never pierce the pressure hull. Images are transmitted digitally over fiber optic cables, not mirrors and glass. Inside the control room, this transformed everything. Instead of peering through a narrow tube, sailors view wide, high-definition panoramic displays. And for the designers, it unlocked something even more important: freedom. The control room no longer had to sit directly beneath the periscope shaft. It could be placed lower, wider, safer, and easier to move through. Even the controls evolved. Early photonics masts used a bulky helicopter-style joystick that sailors disliked. Someone tested a standard video game controller, instead cheap, familiar, and precise. It worked better, so the Navy kept it. Sometimes the simplest solution wins. The Navy signed the Virginia contract on September 30th, 1998. Her keel was laid and Groton the following year. She touched water on August 16th, 2003, and joined the fleet on October 23rd, 2004. Her sponsor was Linda Bird Johnson Robb, daughter of President Lyndon B. Johnson, who gave the traditional order to bring the ship to life. With that, a new era of submarine warfare officially began. At the heart of every Virginia-class submarine is a nuclear reactor designed to last the life of the ship. Known as the S9G core, it produces steam that turns turbines and drives propulsion. Instead of a traditional propeller, Virginia uses a pump jet-shrouded fan that smooths water flow, reduces vibration, and cuts noise. In submarine warfare, noise is death. Less vibration means less sound, and less sound means survival. Officially, the Navy admits the class can dive deeper than 800 feet and exceed 25 knots. The real limits remain classified. Sound dominates everything. Forward of the stern, the submarine is built around listening. Early boats carried a spherical bow sonar, but later Virginia's adopted a large aperture bow array, horseshoe-shaped, water-backed sensor that delivers clearer acoustic data and is easier to maintain. Along the hull run wide aperture flank arrays, acting like enormous ears that stretch the length of the submarine. A high-frequency chin array provides close range detection for navigation and mine avoidance, while additional sensors in the sail assist operations in cluttered or icy waters. Together, these systems allow the crew to extract tiny acoustic patterns from a noisy ocean without revealing their own position. All of this feeds into the Virginia's combat system known as ANBYG-1. Built on an open architecture, it allows the Navy to insert new processors, software, and even machine learning tools without rebuilding the submarine. The hardware stays, but the brain keeps evolving. When it's time to strike, the Virginia relies on a familiar weapon, the Mark 48 Advanced Capability Torpedo. The Mod 7 Seabass upgrade gave it wideband digital sonar, making it far more effective in shallow water and against modern countermeasures. Launched on a guidance wire, the torpedo can be steered during the most delicate phase of the attack before switching to autonomous pursuit. Like the submarine itself, its lethality improves through software. From the start, Virginia also carried Tomahawk cruise missiles. Early boats used 12 small vertical launch tubes in the bow. Later blocks replaced these with 2 large payload tubes, each capable of holding 6 Tomahawks. The missile's published range is around 1,000 miles, and newer variants add maritime strike capability, allowing submarines to hit moving targets at sea. A single attack submarine can now strike deep inland without ever being detected. The biggest leap came with the Virginia Payload Module. Beginning with Block V, engineers inserted an 84-foot mid-body section containing 4 massive tubes, each holding 7 Tomahawks. That adds 28 missiles on top of the bow loadout. The submarine's length grows to about 461 feet, with a submerged displacement of roughly 23 million pounds. Virginia isn't just a weapons platform. It's a tool for invisible missions. The torpedo room can be converted into berthing for special operations forces. A lockout trunk allows divers to exit and re-enter underwater. Torpedo tubes can also launch unmanned underwater vehicles, robotic scouts that map terrain, plant sensors, or take risks humans shouldn't. These systems are already becoming more capable with every test. Life aboard is demanding. A Virginia sails without 140 crew members, living inside a steel tube that contains a nuclear reactor, a machine shop, and everything needed to survive underwater for months. Deployments typically last 6 months, surrounded by long training cycles and heavy maintenance periods. Silence governs everything. Pumps sit on vibration mounts. Panels are secured to prevent rattles. Daily routines are designed to avoid noise. In the sonar room, sailors work in near darkness, listening for hours at a time, searching for whispers in the deep. Success often means no one ever knows they were there. Before Virginia, another class ruled the depths, the Los Angeles class. Born in the 1970s at the height of the Cold War, these submarines were designed to hunt Soviet fleets across the globe. The first, USS Los Angeles, entered service in 1976. Over the next 2 decades, the Navy built 62 of them, more than any other nuclear attack submarine class in U.S. history. They introduced city names instead of sea creatures, a change famously justified by Admiral Hyman Rickover with the blunt reminder that fish don't vote. The Los Angeles class evolved through multiple flights, gaining vertical launch tubes, improved quieting, Arctic capability, and modernized combat systems. They launched the first submarine-based Tomahawk strikes during the Gulf War and set the operational template still used today. Even now, more than 20 remain active alongside Virginia's. Virginia will remain the Navy's workhorse for decades. But SSNX represents where underwater warfare is heading. Faster, smarter, deadlier, and quieter than ever. Thanks for watching. Check out the videos on screen for more unbelievable stories from the depths.